Welcome back to the series on sampling and cluster randomized trials. So in the last set of lectures, we've talked about why do we do surveys? What are the key concepts in the design of a survey? Um, we've talked about our sampling frame. We've talked about target population and the relationship between the target population and the sampling frame. We've talked about um, you know, our sampling design, and we've talked about different techniques for selecting a sample from a target population. We've talked about the simple random sampling. Its simplicity is technical rigor, but also sometimes the difficulty that arises when it comes to implementing the simple randomized sample. And we talked about systematic random sampling, which essentially helps to limit the cost that would be required to do a complete enumeration to generate a sampling frame before a survey actually starts. Now, I would move to one more type of survey. Say, for instance, you have a class right now, and in the class, you have 4,000 students. You cannot go about, you want to collect information from this class about what do students actually watch on their phones? What do students use internet access for? And we want to, on the basis of that survey, we want to make a decision about, should we install Wi-Fi services in the school? Well, sampling 4,000 students might take a lot of time. And, you can have a whole lot of people who do not, you would have to keep on running after before they fill this service. In any case, you don't need to sample everybody. We know that from the introductory lecture. You can get information about this whole population by sampling a subset of the population. So say, after we've done all the calculations, we know that with the sample size we need is 216 people. Now the question arises, does it matter if somebody is a male or a female? Does it matter whether they are in high school or they are in elementary school? It kind of seems like some of these things might matter. And you might be particularly interested in whether the Wi-Fi access should be extended to just high school or to high school and elementary school. And you really want to know, what do high schoolers, what do they watch? What do they use their Wi-Fi? What would they use their internet access for? Now, the problem is, you could do a random survey, but let's say, for example, in this school, this is a school, the students here, you have about 3,800 who are elementary students and just 200 are high schoolers. If you do a simple random sample, the likely thing is that in your sampling frame, you would have just a few, you might have less than 10 high schoolers in your sample. So you'll be able to draw inferences, but will you be able to draw inferences about high schoolers in particular? That might be hard. So if you do not really care about the decision between high school and elementary school, well, that would be fine. You would draw your inference about the population. But if you really care about high schoolers, in particular, then it means that you need to ensure that high schoolers are well represented in your survey. If you do a simple random sample, you might not have enough high schoolers. Sometimes you are not just interested in high schoolers, you're also interested in whether boys among high schoolers use their Wi-Fi services differently than girls among the high schoolers. So if you get just 10 high schoolers in your sample, you get some 3 high school boys, 7 high school girls, you clearly cannot draw any firm, you cannot draw conclusions with any real precision among high schoolers. So to address this kind of problem, where you have interest in certain subpopulations based on certain characteristics, you want to draw inferences about certain subpopulations, and you don't just want to leave it to chance that that subpopulation is adequately sampled in your in your sample, then we approach this problem with an approach that's called the stratified random sampling, which is that before we sample, we separate this population into the different strata that we really care about. So you would separate to high schoolers and elementary schoolers. Generate your randomization scheme separately for the high schoolers and separately for the elementary schoolers. It turns out that as long as we know the probability of selection of a high schooler out of the high school population, and we know the probability of the selection of an elementary student out of the elementary population, we can reconstruct what would have been the proportion in the whole population, given the exact distribution in the population after we have done our sampling. So what I'm saying is, say, okay, we just want to select, we have 4,000 students, we want to select 200 students out of them. We might say, well, if we do a simple random sampling, because out of that 4,000, only 200 are high schoolers. If you do a simple random sampling, you would be getting like, that's out of every 20, you get 1 high schooler. So, I mean, you would get just like 10 high schoolers if your sample were going to be just 200 students out of 4,000 students. You get just 10 high schoolers, and you might not be able to draw precise inferences. But one thing you might do is to say, well, the thing is, let us separate these 200 high schoolers. Out of them, let's randomly select 100. Out of the remaining 2,800 elementary, let's randomly select another 100. So by doing that, we will be sure that in the sample that we will collect data on, there will be sufficient high schoolers and sufficient elementary schoolers to be able to draw firm inferences about high schoolers in particular and about elementary students in particular. Now, somebody might say, well, but this population now does not represent the whole population of the school. If you want information about the whole school altogether, now, would you need to go and do another sample? No. The good thing about the stratified random sampling is that you can look at the strata differently because you have enough power in each of the strata to look at strata-specific analysis. But if we need to now think about the population generally, we can statistically reconstruct the whole population from even these 200 people we have. As long as we know the amount of high schoolers in the whole population, and we know how many we sampled, we know the probability of a high schooler being selected from the sample. And we know the probability of an elementary schooler because we know how many elementary schools are in the population. We know how many of them we selected. We know the probability of every single elementary schooler of being selected into the sample. We know that these populations do not, the probability of a high schooler becomes higher because there are just 200 of them. You selected 100. It means that the probability of each of them being selected is 50%. Whereas for elementary schoolers, there were a whole lot of them, 3,800. You selected just 100. It means that the probability of being selected is almost like 3.8%. So the probability differ a lot. And that takes us to another thing. This solves the problem that we had earlier, which is that we want to be sure that we have enough power to be able to analyze high schoolers and elementary schoolers. But it creates the problem that these 200 people do not exactly represent the distribution of these different kind of people in our population. Now, there's some very smart statisticians have showed us that by using inverse probability weights, which we will describe much later on, we can reconstruct the distribution in our initial population if we want to make inferences about that population as a whole. So this is the beauty of stratified random sampling. In essence, we have each of the sampling approaches has its own advantages and disadvantages. So a lot of times, the choice of which sampling approach is best comes to practical issues. Are there subsets of the population that are particularly important, but yet would need to be oversampled for us to have sufficient power to draw precise inferences about such a population? Is the distribution, the geographic coverage of our target population so large that it would be extraordinarily onerous to generate a sampling frame before we actually start our sample selection? In which case, we might start thinking about a um, a systematic random sampling. So the practical issues. So we need to at least theoretically understand the limitations and the strengths of each of these techniques. But at the end of the day, um, you know, what happens at the end of the day, most surveys are complex mixes of these different approaches. Thank you.